In this video, we are going to discuss about classification of DC machines and later on discuss the applications of DC machines. So in this case, we have the DC machines are classified into generators and motors, but because we're dealing with DC machines or direct current machines, so we have DC generators and DC motors based on the electromechanical energy conversion. Based on the electromechanical energy, DC motors and DC generators based on the electromechanical energy conversion, that is from the electrical to mechanical or mechanical to electrical. That is what we call the electromechanical energy conversion. Or you can categorize the DC machines according to the method of their field excitation. To classify the DC machines according to the method of field excitation, you have separately excited, self-excited, long compound, and short compound machines. That is how you classify according to the method of their field excitation. For example, here you can see a separately excited machine, where you have the fields. There you have the inductor, the resistance, and you have the inductor. This is the armature. This is the resistance in the armature and the voltage at the armature. That is a separately excited machine. And then you have a shunt connected. That means a parallel. Shunt means parallel. And then you have a series connected. Series also sometimes called cascade. Then after that, you have long compound and short compound. A short shunt is a short parallel or a short shunt compound connection where you have the shunt windings or the parallel windings and the series windings connected to the armature, where you have here, this is the inductor and this is the resistance at the armature. Then another class of through the field excitation, you have the long shunt. The long shunt, here we have the shunt windings, the series windings. These here are connected in parallel. Also, these ones are connected in parallel, but in this case, this is short shunt. That is how we classify the DC machines according to the method of field excitation, Moving on, we want to discuss about the application of DC machines. So applications of DC machines. One, the DC machines is extensively used as a motor. The DC is mostly used as a motor in the industry. So that is industrial, where the speed can be controlled over a wide range with the relative ease. And another point, the application of DC machines is that when you have large DC motors, that is in terms of tens or hundreds of horsepower, that is the power. The machines are used in machine tools, printing presses, conveyors, fans, pumps, hoists, cranes, paper mills, textile mills, or rolling mills. That is a case of large DC motors. Another application of DC machines, you can have DC motors dominating the traction of motors that are used in transit cars and locomotives. Locomotives, these are things that are in motion. So when you have small DC machines as compared to large DC machines, that is having a fractional horsepower rating, they are used as primarily as control devices. They are used as control devices. Those are the small DC machines. For example, taco generators for speed sensing and servo motors for positioning and tracking. That is a case of small DC machines. A case of small DC machines are used in control devices such as the taco generators and for speed sensing and servo motors for position and tracking.